All right, so we're going to start our Unit 2. All right, the learning objectives are still coming from the AP Calculus and AP Classroom Unit 1. All right, I separated into two smaller units. Just note that even though I'm calling it Unit 2 on AP Classroom, it'll still say Unit 1 and have the 1 at the start of the learning objectives. All right, so in this one, we're going to talk about asymptotes and infinite limits. All right, so first we're going to define our asymptotes in two different ways. All right, first we're going to start with the way you probably did it in pre-calc. All right, in pre-calc we have this vertical line, x equals a. In this case, a is going to be 2, so we have this vertical line here. And we call that vertical line a vertical asymptote if as x gets close to a, the function grows without bound. All right, so it just keeps getting bigger and bigger. And we can see what happens on this graph as my function value gets closer and closer to this horizontal line, or sorry, vertical line. Then these function values, they start going all the way up there, and on the other side, they just go all the way down to negative infinity. So they're not kind of stopping at any point. They just keep going up forever. That's what the without bound part is. All right, and now in calculus, all right, this whole concept of getting close to something is kind of what calculus is all about. So in this example, all right, for a vertical asymptote, what do we have? Well, we have x getting close to a. That's exactly our limit definition that we were talking about in Unit 1. All right, so x equals, or getting close to a, and then grows without bound just means the numbers keep getting bigger and bigger, and we use the infinity symbol for that. So this kind of simplifies the wordy definition that you had to use in pre-calc, and also makes it a bit more precise with the limit definition. So if your limit, any of the limits, one-sided limits, full limit, if any of those are equal to infinity, if the values just keep getting bigger and bigger, then you have a vertical asymptote. All right, there's one weird thing with this. Even though we wrote an equal sign on the last side, technically, we learned this in Unit 1, that the limit's not going to exist for this when there's a vertical asymptote. All right, so the limit doesn't exist, but we know there's some behavior that we want to talk about. So saying it's equal to infinity is kind of just a shorthand for saying the numbers are going to get bigger and bigger, but it's not equal to a number or anything like that. So technically it doesn't exist, but we have a notation to kind of describe what's happening. Horizontal asymptote, now we're just going to turn everything in the other direction. Now it's a horizontal line, y equals b. In this case, it's going to be 0. And we're just kind of flipping what's going to a number, what's going to infinity. So now, in this definition, x grows without bound. All right, so our x values are getting really, really big, and our y values, our function, gets close to b. Yeah. All right, so in these ones are kind of doing the opposite direction. It's almost like we turned the picture 90 degrees. All right, but the x values now are getting really big, and our y values are kind of leveling off at some place. And now we can talk about that in terms of calculus notation. All right, the first thing, what is happening to our x values? Our x values are getting bigger and bigger, so that part is on the left here. All right, as x goes to negative infinity or in positive infinity, this means we're going to let the x values get bigger and bigger forever. And then what's happening to our y values? Well, as the x values just keep getting bigger and bigger, they kind of just all start getting really close to whatever this number b is. So in the last example, the graphing example, it was 0, but whatever that kind of leveling off point is our horizontal asymptote. And then one thing to consider with your infinite limits as x approaches infinity, basically what needs to happen is your x values need to get closer and closer to that asymptote. Not just kind of get near it once and go away, or get near it again and go away. It needs to really kind of level off and get closer and closer to that horizontal line. So that's what it needs to look like in general. There are some weird ones that kind of look like this, where they go up and down, but eventually they just kind of level off on that horizontal line there. So that's just one thing to consider. So one talking point for this video, and this is actually what we'll start class with, find the limit as x goes to infinity of sine of x. So we're going to start off, and everyone's going to kind of put up their answer for what they think this limit is. Don't Google it or research anything. Just think about what's happening to our sine function if we keep going to infinity. And think about what your answer for this limit would be.